Welcome back again. Today we'll be solving the puzzle from chapter Fractions from the book Ganita Prakash, Class 6, CBSE. So the puzzle is, it is easy to add up fractional units to obtain the sum 1 if one uses the same fractional unit. For example, half plus half is equal to 1. 1 by 3, if we add 3 times, we get 1. 1 by 4, if we add 4 times, we get 1. This is a simple equations which we all understand, like because we are dividing a whole into two halves. So those two halves will make the full whole. Again, if we divide a whole into three parts, then all the three parts will add up to the whole. So this is easy to understand. However, can you think of a way to add fractional units that are all different to get one? So we'll see how we will do in each of the cases, okay? But before that, let us understand what are fractional units. So this is one whole, that is 1 by 1. This is one whole. So the second figure, the shaded part represents half. So the circle is divided into two parts and each part is half. Now the third figure, the circle is divided into three parts, 1, 2, 3, and each part is 1/3. So as we progress from 1 to half to 1/3, we see that the size of the parts are decreasing. So basically, if the denominator is increasing, the size is decreasing. So that this we can understand that the half is greater than 1/3, 1/3 is greater than 1/4, like this. So half is the largest proper fraction, unit fraction. So 1/3 is less than half. 1/4 is less than 1/3. So now that we know this fact, we can start understanding the puzzle. So first is half plus half is equal to 1. So it is in the book, it is said that it is not possible to add two different fractional units to get 1. Half plus half is the same fractional unit we are adding 2 times. But can we add different fractional units to get 1? It's not possible. Why? To get different fractional units, we would have to replace at least one of the halves, but then the sum would be less than 1. So at least one of the halves, if we replace it by another fraction, the next fraction, that is 1/3, these two adding still is less than 1. If you add these two, we get 5/6, which is less than 1. So any other fraction, it will be even lesser. So we cannot add two different fractional units to get 1. So this case is not possible. Now, can we add three different fractional units that add up to 1? Like 1/3 we are adding 3 times, so that is giving 1, that is fine. But can we add three different fractional units? It turns out that there is only one solution to this problem. This is solved in the textbook, but we'll just see to get a feel of how they are solving it. Let's understand the systematic approach given in the book. So this is the starting point. So 1/3 we write 3 times, that is equal to 1. To get the fractional units to be different, we will have to increase at least 1/3 and decrease another 1/3 to compensate for that increase. So how do we increase 1/3? There is only one possibility. The only way to increase 1/3 to another fractional unit is to replace it by half. So now the first unit is half. So what we can write is half plus half is equal to 1. So now we will make the second half as 2/4. Why 2/4? Because we need two more fractional units. So we change this half to, we make an equivalent fraction of half. We can make it 2/4. So that In the next step, we can write it as half plus 1 by 4 plus 1 by 4. These are 3 units. Now we will see what we can do with these two 1/4s. To get the fractional units to be different, we will have to increase one of the 1/4s and decrease the other 1/4 to compensate for that increase. Now, the only way to increase 1/4 to another fractional unit that is different from half is to replace it by 1/3. So now the two fractional units are fixed. They must be half and 1/3. So that's why there is only one solution to this problem. So what must be the third fraction then, so that the three fractions add up to 1? We can add half plus 1/3, that is 5 by 6, and subtract it from the whole, that is 1. So what we get is 1 by 6. So now we see that if we add half plus 1/3 plus 1/6, all these are different fractional units. They all add up to 1. To visualize this, we can see this diagram. The green parts portion represents half, the orange represents 1/3, and the blue one represents 1/6. So this add up to make the whole circle. So these two parts are solved in the book. So the final part we will now see. Can you find 4 different fractional units that sum up, that add up to 1? It turns out that this problem has 6 solutions. Let's take a similar approach as given in the last two problems. So we will add all these 1/4s and make it 1. So now let us fix the largest unit fractions. We know it can't be 1/4. Why? Because if the first one is itself, the largest one is 1/4, then all of them have to be 1/4 only. If we replace any of the 1/4 with a smaller fractional unit, then how can the total sum be greater than equal to 1? It will be less than 1, right? So the largest one cannot be 1/4. So it can be only 1/2 or 1/3. Either half or 1/3. So let us see. So it can be either half or 1/3, but can it be 1/3? Let's fix the first one as 1/3, and if we add the progressively next fractions, next bigger ones, then all the 4 ones, if we add, we get 57 by 60, which is less than 1. So this is also not possible. The largest one cannot be 1/3. Because why? Because if we take the next largest one, that is 1/4, and the next largest one, that is 1/5, and the next largest one, that is 1/6, and add all these unit fractions, we get a number 57 by 60, which is less than 1. So we can discard the case of 1/3. So the first largest unit fraction has to be 1/3, half. So it has to be half. It cannot be 1/3. The reason we saw is this reason. So now we know that half plus half is 1. So first one is fixed at half. So the other 3 unit fractions must add up to half. So other 3, because we need 3 more. So we will make this half as equivalent fraction. We will make the numerator as 3 and the denominator as 6. So we can write as half plus 3 by 6, because we need 3 more. Because we want finally 4 unit fractions, right? First one is fixed at half. So we need 3 more. That's why we made it as 3 by 6. Now we can write it as 1 by 6, 1 by 6, 1 by 6. And now we can apply the similar approach that we applied for the 3 fractional units. To get the fractional units to be different, we'll have to increase at least one of the 1/6 and decrease another 1/6 to compensate for that increase. So, what are the possible values of the second largest unit? It can be 1/3, 1/4, or 1/5. It cannot be half because half is already fixed. And it cannot be 1/6 also because we have to increase it from this value, right? So one value has to increase. So it can be 1/3, 1/4, 1/5. These are all greater than 1/6, all these values, right? So now let us examine each case. So the second largest fractional unit is 1/3. So we can rewrite it as first two are fixed, half plus 1/3. And we know that the next unit has to be 1/6. So now we have to break this 1/6 into two parts. So we make it as 2/12. So we rewrite it as half plus 1/3 plus 2/12. And now we can further break it like 1/12, and 1/12 we can write instead of 2/12. So we get four fractional units, but these two are same. So what we will do now? So if it is difficult for you to visualize this thing, then we can even approach it in a different way. We can write, because the two fractions are fixed, half plus 1/3. So we can subtract it from 1. We will get 1/6. This 1/6 needs to be broken into two fractional units. So we can write it as 2/12. And then we can write 1/12 plus 1/12. So now to get the fractional units to be different, we will have to increase 1/12 and decrease the other 1/12. So what are the possible values of the third largest fractional unit? It can be 1/7, 1/8, 1/9, 1/10, and 1/11. Why? Because it should be lesser than this number and greater than this number. So all the numbers starting from greater than this denominator is greater than 6 and the denominator is less than 12. Those numbers we have to consider. So all these fractional units, let us examine each of them now. So the third fractional unit, let's examine each. So what we have to do is, we now, instead of 1/12, we will replace it with 1/7 and find the other one, because these two are same. So we have to replace one with a lesser and one with a greater number. So first we will both the things should add up to 1/6. So if we fix it at 1/7, then if we subtract it from 1/6, if are we getting another unit fraction? Then this is a valid case. So if we subtract 1/7 from 1/6, we get 1/42. So this is also a unit fraction. So this is a valid case. So again, next one is 1/6 minus 1/8. This is also a unit fraction, that is 1/24. So this is also valid. The next one is also valid. This is also valid. This is not valid. So we will not consider this 1/11 case. So with first two as half and 1/3, we have four solutions. These are the four solutions. So next, let us fix the second largest one to 1/4. We already saw this case with 1/3. It gave four numbers, four set of unit fractions, different unit fractions. Now we will start with try with 1/4. So again, we can write it as these two are fixed, 1/2 and 1/4. So the remaining amount is 1/4. So now we can write it as 2/8, which we can again expand to 1/8 and 1/8. We can again see it in a different way. Same thing we will do is look at in a different way. We subtract the sum of these first two fractions from 1. So we get 1/4. Now we can write 1/4 as 2/8 because we need two more fractions, unit fractions. So we now make it as 1/8 and 1/8. Now similarly we will approach this also. So we'll have to increase 1 by 8 and decrease the other 1 by 8. So what are the different possible values of the third largest fractional unit? The possible values are, it should be greater than, the denominator should be greater than 4 and it should be less than 8. So the denominator 1 by 5, 1 by 6 and 1 by 7 are the unit fractions with those denominators. So let us examine each case now. So to get the fourth fractional unit, if we fix the third one as 1 by 5th, so what we have to do, we have to subtract 1 by 5 from 1 by 4. So let's see the values. This is 1 by 20. This is a valid case. The next one is also valid. But the last one, 1 by 4 minus 1 by 7, does not give a unit fraction. So 1 by 5 and 1 by 6 are valid, but 1 by 7 does not give a unit fraction. So we have two different set of unit fractions. So with the first largest as half and the second largest as 1/4, we get two different set of unit fractions which add up to 1. So there is one more case, the case of 1 by 5. If the second largest unit is 1 by 5. So what happens is, we will subtract the sum of these two fractions from 1. We get 3 by 10. This 3 by 10 we can write it as 1 plus 2 by 10 and break it into two different fractional units. But 1 by 5 is already there in the second term. This is a repetition. So this is not a valid case. There's another way to look at it is, if we fix these two fractions and the next largest one if we take and the next largest one if we take, the answer is 212 by 210, which is greater than 1. So we can check some other case also. So instead of 1 by 7, we can take 1 by 8. We see that this is less than 1. Less than 1. Only valid solution therefore are the second largest fractional units with 1 by 3rd or 1 by 4. So we have found all the 6 ways. So first and second largest fractional unit is half and 1/3. We have 4 solutions. And with first and second largest fractional unit as 1/2 and 1 by 4, we have 2 solutions. So there are total number of 6 solutions. You can note down all the 6. And that's it from my side today. So please like, subscribe, share and comment. Thank you.